All right, we looked at rounding the decimals. Now we can also look at comparing the decimals and then placing them on number lines. Okay, so when you're comparing decimals, right, when you're determining which is greater, you're going to compare like places, right? So you compare the like places from left to right. So note that just because one number has a quote-unquote larger decimal part than another does not necessarily mean that it's greater. So if we look at 5.75 and 5.8, right, this is 5 and 75 hundredths. This is 5 and 8 tenths. So if you compare place by place, right, well, they have the same ones digit, so that's equal. But then you don't look at 75 versus 8 and say 75 is greater. No, you compare the 7 with the 8 and you say, all right, 8 is greater than 7. Therefore, 5.75 is actually going to be less than 5.8, right? Because 8 is greater than 7. So then you do the same thing with these. They have the same ones digit, but even here, the tenths place, that has a 5 and that has a 6. So 6 is actually greater than 5. So again, you're going to have 9.512 is less than 9.67, right? That's 9 and 512 thousandths, and this is 9 and 67 hundredths, right? So you're just comparing the like places. All right, and then last one, same thing. Compare the ones, they're equal. Now compare the tenths. Well, this is a 2 and this is a 1. But now these are negatives that you're dealing with, right? So it's kind of the reverse. So you think of the 1 as being less negative than the 2, right? So this 1 is actually going to be greater than the 2 because it's less negative. So this negative 3.18 is greater, which means that negative 3.2 is less than negative 3.18, right? Because this, it's less negative, so it's greater. But the idea, again, the key is to compare the like places from left to right. That's what you're doing, right? So, because if you just looked at these, you would say, oh, hey, 512 is greater than 67. No, the 6 is greater than the 5, so that's greater. 75 is greater than 8, sure, but that 7 is actually less than that 8, right? So you got to compare the like places. So similar to what we had done with fractions, we're going to do the same thing with decimals, ordering them on number lines, placing them on number lines. But in a lot of cases, decimals are easier because what you can do is you can usually just break them up into like tenths, right? Which is what's nice, right? So like with this, what do I have? I have 0 0.4, 0 0.9, negative 0 0.74, negative 0 0.63, so on. So I don't have anything that's less than negative 1, and I don't have anything that's greater than positive 1. So everything is between negative 1 and positive 1. So if I was going to um, label this number line, I would put negative 1 all the way on the left, and I would put positive 1 all the way on the right. Okay, now I'd have 0 halfway in the middle. And then now, most of these are tenths. They're not all tenths, right? Like there's some thousandths, there's some hundredths, but most of them are tenths. So the easiest thing to do usually when you're going to place decimals is break it up into tenths. Okay, so if I have 0 and 1, halfway would be 0 0.5. And then remember, I would need now 6, 7, 8, 9, 0.6, 0.7, 0.8, 0.9 here. And just do the best you can. Here I would need 0 0.1, 0.2, 0.3, 0.4. Then over here I'd have negative 0.5 halfway. Then I'd have negative 0.1, negative 0.2, negative 0.3, negative 0.4, and then negative 0.6, negative 0.7, negative 0.8, negative 0.9. Okay? And remember again, we had done this when we did fractions. Between 0 and 1, if you're breaking it up into tenths, there's actually 1, 2, 3, 4, 5, 6, 7, 8, 9 more numbers between, 9 more ticks, right? Those marks, 9 more marks between 0 and 1 if you're breaking it up into the tenths, because you think of 1 as the 10th one. So there's 9 more. And the same thing over here. Between 0 and -1, there's 9 more tick marks. So just keep that in mind. All right. So now you would just place these, and a lot of them are going to be able to go exactly on one of the tick marks. So like 0.4, that's 1, 2, 3, 4. 0.9, 0.6, 0.7, 0.8, 0.9. Negative 0.74, well, here's negative zero point 0.7. Here's negative zero point 0.8. So negative 0.74 would go between these, slightly closer to negative zero point 0.7. So it would go like here. Negative 0.63, well, here's negative 0.6. Negative 0.63 would be a little closer to negative zero point 0.6 than negative zero point 0.7. And then negative 0.25, 0.1, 0.2, negative 0.25 would be smack dab in the middle of negative 0.2 and negative 0.3. So that goes there. And then 0.04, here's 0, here's 0.1. So 0.04 would be a little bit closer to 0 than it would be to 0.1. So that's 0.04. And then negative 0.83. Well, there's negative 0.8. Negative 0.83 would be a little closer to negative 0.8. And then negative 0.083, this is a good distinction, right? Negative 0.083 is not even negative 0.1. So it's between 0 and negative 0.1, and it's actually going to be pretty close to negative 0.1, right? It'll be like maybe here, negative 0.083. And then 0.75, that'll be halfway between 0.7 and 0.8. And then 0.705, it's close to 0.75, but it's just to the right of 0.7, right? Because it's 0.705, right? So 0.705 would be like right there. It would almost be on that same mark as the 0.7, right? So that was that was a tricky one to do because that was very close, right? When they're that close together, it becomes a little tricky. But that's the idea. So usually when you're doing decimals, you can break them up into tenths, which isn't too bad, right? It makes it fairly easy. It's easier than fractions. And then adding, subtracting, and multiplying, not a huge deal. The only thing to remember is you you can only add, and it's similar to adding common denominators, right? Like just do a simple example. Like let's say I had 2.25 plus 3.5, right? I can only add things that have common denominators. So what I want to do is 2 and 3 are whole numbers, so I can add those, right? So I could do 2 plus 3, that's 5. Now, this 2 here, that 2 after the decimal point, that really means 2 tenths. This 5 really means 5 tenths. So I'd add those and I get 7 tenths. And then that 5 is 5 hundredths. There's no hundredths place to add it to, right? So that 0 would get added to that 5 hundredths. So this is kind of a way, I mean, you would never do it this way, but this is the way you can think of what you're doing, right? You're adding the ones, you're adding the tenths, and you're adding the hundredths, but there was no hundredths here to add. So then if I add these things together, what do I get? I get 5 and 7 tenths and 5 hundredths, right? So 5 and 7 tenths and 5 hundredths, because you can think of this number as being 5 plus 7 tenths plus 5 hundredths, right? So again, would you ever do it that way? Of course not. What you would do is you would just say, I don't know, 32.15 plus 27.862, right? I would line them up, which they're not lined up right now. This is bad, right? I would have to put this 5 probably here. And now if I'm missing a place, I just add a 0 there, right? So now I would add up these like places. So 0 and 2 is 2 because that's the thousands. 5 and 6 is 11. That's the hundredths. So then I would put down a 1 and carry a 1. And then 8 plus 1 is 10. I would put down a 0 and carry a 1. 7 plus 2 plus 1 is 10. Put down a 0 and carry a 1. 3 plus 2 plus 1 is 6. So that's 60.012, which is 60 and 12 thousandths, right? And again, the idea of carrying is once you get to a 10, you would have to go on to the next place, right? Because we only have 9 digits per place. So we'd have to carry it over to our next place to the left, right? And as we go to the left, we multiply by 10, right? Because really 1 is 10 times 1/10. A tenth is 10 times 100th, so on and so forth. And then what we do is multiply and divide by powers of 10. This is just something that you should probably know, right? Like if I'm multiplying 45 times 10,000, what do? Right? I basically just think of this 45 as being 45 with a decimal point after it. And since I have 1, 2, 3, 4 zeros here, I'm going to move my decimal point 4 to the right. So 45 times 10,000 really becomes 450,000. And then similarly, when you're dividing, right, if you have 873 divided by 1,000, again, you think of 873 as being 873 with a decimal point after it. So when you're dividing by 1,000, you can think of it as you're just sliding this decimal over 3 to the left. And you end up with 0.873. Okay? So you're just moving the decimal point either to the right or to the left by however many zeros are in that power of 10. So that 1,000 had 3 zeros, so I slid 3 to the left. Here, 10,000 had 4 zeros, so I slid 4 to the right.